Hello everyone. In this video, I'm going to explain what is Kubernetes, key components of Kubernetes, and architecture of Kubernetes, how it works, and what are the how the networking part and storaging part works in Kubernetes, and what are the popular tools using Kubernetes. So let's see what is Kubernetes. Kubernetes is a powerful open source container orchestration platform. So, initially, it is developed by Google. Now, it is maintained by the Cloud Native Computing Foundation. So, why we need Kubernetes? So, Kubernetes will helps you manage and run application in containers across the multiple computers. So it automates the deployment, scaling, and management of containerized application. So it let developers focus on their code while Kubernetes keeps everything running smoothly and adjusts as needed. Now let's see components of Kubernetes. So these are the components of Kubernetes. First one is kubectl, API server, scheduler, control manager, etcd, kubelet, kubeproxy, pod, and container. So in the upcoming slides, let's see these components in detail. Now let's see architecture of Kubernetes. So this is the architecture of Kubernetes. So this is the user interface. It helps to communicate with the control panel or the Kubernetes architecture. Uh, now the kubectl. So kubectl is a command line tool for interacting with the Kubernetes. Think of it is a remote control for your Kubernetes cluster. So in the control panel, there are the component are there API server, scheduler, control manager, and the etcd. Now let's say what is API server. So think of API server as the reception of the desk for the Kubernetes. So it handles all the requests and make sure every people and other components can communicate with the system. And next one is scheduler. So scheduler it decide which machine or which node is the best fit based on available resources, and it's like a matchmaker that balance workload across the machines. The next one is control manager. The control manager it continuously check if everything is running as expected. If something goes down, it steps in to fix it and make sure system stay in its desired state. The next one is etcd. So etcd keeps track of everything that happening in the cluster, including configuration and settings. If the system ever needs to remember what the setup was, it looks here. So this Kubernetes architecture is like a master and slave concept. So control panel is worked as the master node, and these are the worker node. So the master node will assign the works for the worker nodes. So now let's see what is pod. So pod is a group of one or more containers that shares the same network and the storage and the resource. It is the smallest unit deployment in the Kubernetes. So what is containers? So container is like a lightweight and a portable package that hold the application and all of its dependencies like libraries, files. So that can be easily run anywhere. So kubectl, sorry, kubelet. So kubelet it makes sure that container are running as they should on the particular machine. The kubelet communicates with the API server and follows instruction to manage local containers. And the queue proxy, it will manage the network roles on the each machine to help application communicate with each other smoothly, like routing traffic between the different part of your application. Now let's see key Kubernetes objects. The first one is service. The service act as a stable front door for your application. So they ensure that your application can be found at the fixed address like a IP address, even if the specific part of your application are changing in the background. The next one is deployment. Think of this as a blueprint of your application. It defines how many copies of your application should run, and if something goes wrong, it helps keep the application running as expected. The next one is configuration map. So imagine you have some settings like database URLs or the feature flags that you want to keep separate from your code. So config maps let you manage this configuration data separately, so you can update settings without changing or deploying your application. The next one is secrets, like config map, but for the sensitive information like password or the API keys. So secret stores this data in a secure way, so that can only part of your application that need access can see it, and keeping sensitive data protected. Now let's see how the Kubernetes works. The first step is set up your application. You start by writing a configuration file in the format of a YML. So to tell Kubernetes what you want your application look like, and how many part it has, and what kind of resources it needed, etc. Like that. And the second step is send a configuration to Kubernetes. So after setting your application and writing your configuration file, then you give the this configuration file to Kubernetes, so it can read it to understand what you want your application do and how it should run. After send the configuration file to Kubernetes, uh, Kubernetes takes over. It automatically find a good spot to for your application to run in the cluster. Keep it running and fixes restart it. And if there is an issue, to make sure everything stay as you set up it. So this is the example Kubernetes configuration file. So let's see how it works. So we need to save this file in the extension of .yml. So initially we need to specify the API version. So it specifies the version of your Kubernetes API we are using, like that in here for deployment. It's a apps slash v1. And the next we need to specify kind. So it defines what type of Kubernetes resource this is, and here it's a deployment, so which controls the creation and scaling of pods. So next we need to specify metadata. So metadata gives a basic information about the resource, such as its name. In this case, Nginx deployment is the name of the image, and the labels. So it's label like a add tags to categorize or identify the resources useful for searching and organizing. So next is specification. So it defines the setting for this deployment. So here we need to specify the replicas. So it specifies the number of pods to create. Here we start with the just one replica. Next, we need to mention a selector. So selector matches pods that we have a specific label, helping Kubernetes know which pod is this deployment manages. Next one is templates. In the templates, metadata add labels for each pods, so Kubernetes know they belong to this deployment. Here, containers. Sorry, here we need to specify the specification. So it describes the what each pod should run. So container defines the container inside the each pod, and the name specify the it pulls the Nginx web server image version 1.21 from the Docker Hub. So here we need to open the port number 80 inside the container, so it can server web request. After creating this file, we need to run this file with the help of the command kubectl apply -f. F stand for file. So and name of the file, that is nginx deployment.yaml. Now let's see what networking in Kubernetes. So in Kubernetes, networking is essential for allowing communication between different part of the cluster, like nodes and pods, and exposing services and ensuring security. So first one is cluster networking. So this is the system that allows all the nodes and the pods in a Kubernetes cluster to talk each other. And the next one is service type. So services are how Kubernetes expose the application to the outside world or within the cluster. The main type of the services are cluster IP, node port, load balancer, and ingress. Now let's see what is cluster IP. So a cluster IP is a service is only accessible within the cluster. So it is used to it is used to let the application inside the cluster tag to each other. And let's say meaning of the node port. So this makes the service accessible from the outside of the cluster by opening the specific port on the each node. And the load balancer. So this service type creates an external load balancer to distribute traffic across the multiple pods, so commonly used in a cloud environments. Now let's see what is the meaning of ingress. So ingress is a more advanced option that manages external access to service in a cluster. So often used for handling HTTP or HTTPS traffics and sending up custom routes. Now let's see storage in Kubernetes. In Kubernetes, storage is managed through volumes. So volumes in Kubernetes provide a persistent storage, which is especially important for application that needed to remember data even after restarting or moving between nodes. For example, if you have a database running in a Kubernetes, so you will want it to keep data across restarts. So let's see type of volumes. So first one is persistent volumes and the persistent volume climbs. So these are let's see what is a persistent volume. These are storage resources created by administrators, and they exist outside of any specific container. Think of persistent volume like a preset storage space that application can use when needed. So, persistent volume climbs are requests for storage by applications. So, application use a persistent volume climbs to climb a certain amount of storage, and Kubernetes matches these requests to the existing persistent volumes. And the third one is storage classes. A storage classes is like a blueprint for the type of storage you want. So it allows Kubernetes to automatically provide the storage type best suited for the application. whether it's fast storage, slow storage, or the storage on a specific cloud provider. Now let's see popular Kubernetes tools. So first one is kubectl. So it's a command line interface to interact with the Kubernetes, and software called Helm. It's a package manager for Kubernetes, and the Prometheus. It's a monitoring tool for the Kubernetes, and the Grafana. So it's a visualization tool for the monitoring. So till here, guys, you have seen what is Kubernetes, key component of Kubernetes, and architecture of Kubernetes, how the Kubernetes works, and example of the Kubernetes configuration file, and how to run that file, and what are the popular tools for the Kubernetes. So thank you guys for watching this video.